Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Minimum number of swaps to make the string balance, Leetcode 1963. In this problem, we are given a zero index string S of even length n. The string consists of exactly n by 2 opening brackets and n by 2 closing brackets. A string is said to be balanced if and only if it is an empty string, or it can be written as AB, where A and B are balanced strings, or it can be written as C between square brackets, where C is also a balanced string. We may swap the brackets at any two indices, any number of times, and in the end we should return the minimum number of swaps to make string S balanced. So this definition looks confusing, but what they are trying to say is we are given the string where the brackets may or may not be balanced, but in the end we have to return the minimum number of swaps to make the string balanced. Then in example 1, for the given string, we can swap one pair of brackets at index 0 and 3 to make the string balanced. So we will return 1 as an answer. Similarly, in example 2, we can swap index 0 and 5 and then index 1 and 4 to make the string balanced. In this case, number of swaps were 2, so we will return 2 as an answer. And finally, in example 3, the parentheses are already balanced, so we will return 0 in this case because we don't need to swap anything. Now, before diving into the solution, let's look at a problem bit closely. First of all, it is guaranteed that the total number of open square brackets are equal to total number of closed brackets. And to make the string balance, we need the open parenthesis before close parenthesis. For example, this is a balanced string because we can form two of these balanced pairs. So in this case, number of swaps will be 0. But now the question is what causes imbalance? Let's look at the example here. As the string starts, we see a closing bracket and we can see that it already creates the imbalance, which we have to fix by swapping the brackets. So our string then becomes like this. So number of swaps here will be equal to 1. So here number of swaps were equal to number of imbalances. So how about we count the imbalances in the string by counting the excessive close brackets or number of close brackets before open brackets and derive number of swaps based on that. And why counting the excessive close parentheses will be enough because we can ignore the balance segments of the input string as they don't affect the overall balance. So whenever we find a closing bracket, we can increment the count, and whenever we find the opening bracket, we can reduce the unbalanced brackets by 1. Also, this was an easy example because we only had one swap and one imbalance to fix. And in this example, it looks like there is a 1-to-1 ratio between swaps and imbalances. But let's look at more examples before we draw any conclusion. Now for this string, we start counting unbalanced close parentheses. Initially, imbalance count is equal to 0. Then we see close parentheses, so we increment the count by 1. Then we see close parentheses 2 more times, so we increment the count twice. And now our imbalance count becomes 3. Now we see open square bracket, so that can bring the balance, so we reduce the count to 2. Then we see more close brackets, so the count becomes 1 and then 0. The largest imbalance we have is 3, and this maximum value pinpoints the largest deviation from the balance in the string. And now, if we have 3 imbalances in the string, how many swaps should we have? Technically, one way to swap can be that we swap these two parentheses. So that will be one swap. Then we swap these two parentheses. That will be another swap. And then we again swap these two parentheses. So that will be third swap. So if we do it this way, then we have total 3 swaps. But the problem wants us to return minimum number of swaps. So this is not the correct way. And that's why let's look at the swaps a little more closely. With one swap, actually we can fix two imbalances. For example, this closing bracket that was contributing to the imbalance is now replaced by opening bracket in the sequence, correcting the immediate imbalance. But this missing opening bracket was causing the subsequent imbalance is now correctly positioned, balancing a future imbalance too. And in this case, we will get the string like this one, where we fix two imbalances instead of one, and now these two parentheses become balanced. And now there is only one imbalance remaining, that is this character and this character. And for one imbalance, at least we have to make one swap. So number of swaps here will become 2. So now we can come up with a strategy that in one swap, we try to fix two imbalances, and then if the number of imbalances are odd, then for that imbalance again we have to use one swap. So number of swap will be equal to imbalances plus 1 by 2. So for example, if we do 0 swaps, that means number of imbalances in the string were 0. But if we do one swap, then either we can fix one imbalance or two imbalances. Similarly, if we do two swaps, then either we can fix three imbalances or four imbalances. So this is why this formula works. And now let's look at the final example to crystallize our learning. So this is even bigger string, and here these two parentheses are balanced already, so I'm just marking it in green. So again we count unbalanced close parenthesis, and maximum it reaches is 3. So number of swaps will be number of imbalances plus 1 by 2, that is 3 plus 1 by 2 equal to 2 in this case. Now for example we swap these two brackets. With this again we fix two imbalances, one for the current and one for the future. So now this and this string is balanced, but these two are still unbalanced. So we can just swap both of them. So now this will be a second swap. So number of swaps is again 2. So the intuition behind this problem was important, and that's what makes this problem the medium one. But the code for this problem is super small. First, let's define imbalance to track maximum number of closing brackets and count to track current imbalance of brackets. Now we iterate through each character of the string and check if character is opening bracket, then we will reduce the count because it brings the balance. Otherwise, if the character is closing bracket, then we will increment the count. And at each point we will check if count is more than imbalance. That means we should update imbalance to current count to get the maximum imbalance. And in the end, we will return number of swaps as imbalance plus 1 by 2. Now let's run this code. Let's submit this code. Cool. In terms of time complexity, it will be O of n, where n is number of characters in the string because we are going through each character only once. And in terms of space complexity, the auxiliary space complexity is O of 1 because we are not using any extra space other than the provided string. So I hope this video was useful to you. If it was, please like, share and subscribe. The code link is in the description below. Thanks for watching. See you next time.